Problem 4.85 from Chapter 4. We've got to have a balanced equation since this is a stoichiometry problem. You know it's a stoichiometry problem because it's a titration. You know it's a stoichiometry problem because you're given quantities of two different reactants and you have to do something with it. You're told you've got 2.5 molar HCl and that is reacting with 4.36 grams of MOH. Now you've got to know something about titration in order to go much farther on this question. You've got to know the significance of an equivalence point so that you understand what the 17.0 milliliters of HCl means. And so I got a video coming up that just gives you a brief overview of titrations.
A titration is a controlled acid-base neutralization reaction. 20 milliliters of hydrochloric acid of an unknown molarity is added to a flask. 2 drops of indicator dye are added to the acidic solution. This indicator dye is clear in acidic solution and pink in basic solution. The burette is filled with a sodium hydroxide solution of known strength and an initial reading is taken. The base is added to the acidic solution until the solution stays a slightly pink color. At this endpoint, a final reading is taken. The moles of base added equal the moles of acid present. This same reaction can be followed using a pH meter instead of an indicator dye. Initially, the pH changes very little as base is added. Suddenly, the pH changes rapidly as the endpoint passes. The solution quickly becomes very basic, and again the pH changes very little. The endpoint occurs at this middle point on the curve.
So I hope that video was helpful to get you oriented to what titrations are, kind of what they look like. So we're going to find the number of moles of HCl because at the end point or the equivalence point, the moles of acid and base are equal. And so if we know the number of moles of acid, we can find easily the number of moles of base. So molarity times volume, converting milliliters to liters, of course, is going to give us the number of moles of HCl. Stoichiometry tells us that there's 1 mole of MOH for every 1 mole of HCl. That calculation gives us 0.0425 moles of MOH. Now we have to find the molar mass. You know that molar mass is the gram ratio of mass to moles of a substance, so it's grams per mole. Well, we know the number of grams that were consumed, 4.36 grams of MOH. We know the number of moles, that is 0.0425. So 4.36 divided by 0.0425, and that will give us the molar mass of that compound, which is about 102.59 grams per mole. So the molar mass is 102.59 grams per mole of the MOH. That's simply the sum of the atomic masses of the metal, the oxygen, and the hydrogen. We don't know M. We know O. We can look that up on the periodic table. We know H. We can look that up on the periodic table. And then it's a simple calculation to figure out what M is. M is 85.58 grams per mole. Go to the periodic table. Look for the metal that has a mass, atomic mass of 85.58, and you'll find that that is rubidium.